This is Intro to Java. This is week 8. We are moving into unit 4, which begins to cover chapter 4. But I did want to do just a tad bit of backtracking here to look at a couple of important concepts in chapter 3, because I didn't get a chance to lecture on these and include them in a video. I wanted to point your attention to this particular concept, and that is every time we create a class file, we are creating what they refer to as an abstract data type, or ADT. They also call them programmer-defined data type. But really, whenever you create a class, it really is a data type. And they will use some example here. Let me see if I can find one. And basically, whenever you are invoking something in this fashion, in other words, we are creating a new variable called temp emp, or employee. And what data type is it? It's employee. And what's employee? It's the class we created. So just like we declare any other kind of a variable, like here we might say int id equals whatever. Here we say employee temp employee equals new employee, and notice that employee is what? When you see parentheses after something, it is a method. Okay, so what this method does is it goes to the class file called employee and creates a new version of it, a copy of the blueprint, and then this takes on all the properties that are embodied in that data type. So whatever variables are inside there, and then we use the get and the set methods to create it and send it back. All right, so we've been using this now for a while, ever since we've been doing inputs, and you'll notice that the scanner is a standard tool that's actually part of this library of classes and objects and methods. And whenever you see that word new, that indicates we are creating a new one. Now, tying into that topic, I'm actually stepping backwards to page 156 at this point. And I just want to point out the fact that when you see a statement like this, it is called a constructor. So it means we are constructing that new version, or we're instantiating that class. We're creating an object from the class. So it's a new chauffeur based upon employee. All right. Here, this is kind of important too. It says a default constructor is one that requires no arguments. Right? Arguments being the things that go inside the parentheses. Because all we have to do is create the object. But if we want to give it particular values, we can. It just depends on what type of thing it is. Like when we do the scanner input thing that we were just looking at just a few moments ago, that does have system in that goes into it, because that triggers a different thing to happen within that particular class. All right, that's going to wrap all the stuff I want to say about chapter 3, and we are going to move now to chapter 4. Now let's take a look at chapter 4, and you can see that we're continuing the topic of working with objects and classes and methods, but we're looking more at just a whole point of objects. This is a list here of some of the things that we're going to look at. We're going to talk about blocks and scope. Overloading, that's kind of a new one. All right, so they're going to use constructors now with parameters, meaning where we are going to send things in. And this thing, what is this? This is this. And you'll get, that's kind of a confusing little construct, but it does happen in many different languages. but it's basically self-reference is what that means. How we'll use static fields, and these other couple of topics here. Now, before I continue on, I do want to jump over to Blackboard real quick. And in the Unit 4 folder, I do want to point out the fact, and I'm sorry, it's not in this particular folder. I do have a video here from a previous class which you can watch to help with some of these concepts, but I guess it was in the Unit 3 folder, where I have a video link about some of these topics, and I also have these 2 links to websites that I would encourage you to look at, because this is such a important feature of the Java language. It's kind of good to get a few different viewpoints on it, because I might describe it one way. You know how the author writes, and it's not always the clearest thing because he's trying to like make sure he covers everything about every topic. So sometimes you miss the important parts of it just because of the way it's presented. So what I would recommend is that you read through some of this stuff, and I mean, like, for example, if I look at these couple of descriptions here, it says objects have states and behaviors. Example, a dog has states: color, name, breed, as well as behaviors: wagging, barking, eating. All right. And then an object is an instance of a class. So a class can be defined as a template or blueprint that describes the behaviors and states that object of its type support. So if I create a generic class of dog, I will put in the capability to set the color, the name, and the breed, but also we can set up behaviors, and behaviors of course will relate to methods that might include these things. Is it wagging its tail? Is it barking? Is it eating? Etc. So these are kind of like the physical properties, and these are the actions. So that's kind of an important thing that we really haven't thrown in yet, or at least clarified in that way. So maybe that helps you to understand it a little bit more. This other link, and this one's right from Oracle, the people that now own Java. It was originally developed by Sun Microsystems, if you remember that company. And Oracle, which is the big database company, eventually bought Sun Microsystems, and now Java is part of their family. Here in this particular web page, they do have a few links to a number of different things, and the ones that I'll point you to here are these 2. One is object-oriented programming concepts, and then classes and objects, and they go through and they start talking about these things, and you see how very brief the descriptions are. And I think that it's really a good idea for you, if you haven't already, is to look at an alternative source. And really you should do that with anything that you're learning, because one instructor or writer or article or whatever it is will have their own approach to presenting material, and it does not resonate with everybody. When I'm learning a new concept or learning a new thing, I'll do that myself. Also, don't be afraid to go out to YouTube and look stuff up, although watch the dates, the published dates, and look at how credible the person might be. Or you can go to like Linda and watch their stuff. Their stuff is excellent. They don't put out anything that's junk. It's all top-notch. All right. All right, so they talk about this here one more time. There are some other components here that we will cover later. But if you look at their description, it says an object is a software bundle. Okay, well, we really haven't done software bundles, but we have done, an instance of a class. So it's a software bundle of related state and behavior. So that's kind of the same thing they said before. They're often used to model real-world objects that you find in everyday life. This lesson explains how state and behavior are represented within an object, introduces the concept of data encapsulation, which we will cover later, and explains the benefit of designing your software in this manner. And then their definition of a class, it says a blueprint or prototype from which objects are created. We've been saying that, and hopefully it's sticking now. The section defines a class that models the state and behavior of a real-world object. It intentionally focuses on the basics, showing how an even simple class can cleanly model state and behavior. All right, so two different approaches from the ones that we've had. So said in a few sentences, that might be clearer for you. So hopefully that's of some help. Right, Kelly was just pointing out here that if we do come in here and click on these, it does give you examples. So I would recommend that you actually come in here and just take a look, even if it's just a brief one. And this stuff here you should already kind of understand, I'm hoping. This is kind of an interesting little one where a bicycle, cadence, speed, and gear. You can change gears. And these are kind of like getting sets. So let's go ahead and get back into Chapter 4 and let's go through some of the material here and work on some of the exercises. One of the things they begin talking about are blocks and scope. A block, in essence, is just a collection of programming statements. So wherever you see curly braces, where you see one start and end, what's inside of it is a code block. It's a block of code. That's all it means. They go through, describing inside block, inner block, The important thing to just remember, as far as I'm concerned, is like, for example, all of this, is that a block? It's not, because this statement's not part of it, but everything inside the curly brackets, that is a block. That's a block. It's a code block. Okay. Now, these are the important parts to start to latch onto. And it says when you declare a variable, you cannot refer to that variable outside its block. So if I make a method and create a variable like this one, if I try to print it out down here, so if instead of like saying a number, I used another number, it won't work because it's not in between those two curly brackets. That's what that's telling you. Now, that concept is referred to as scope. So if it's inside the curly brackets and you're using that variable, it's considered in scope. You're able to use it. If it's outside, it's out of scope. So that's a pretty important programming concept. You probably have heard of that in your other classes, I'm hoping. Variable scope. Let's take a look at this example at the bottom of page 181. And they tell us obviously like what doesn't work. So here they have a method called method with invalid statements. Thank you very much. It's chock full of them, right? So here they define a variable in the second line. Because this first line appears before it, it won't work. First you have to say that it's an integer before you can go giving it a value. Okay, so to fix this, we would need to move this second line above it. Afterwards, we can go ahead and change the value. Here we have another one that's in the same category. This one also has not been declared yet. Then notice that we have a block, a code block, and once again, they're throwing it in there, no variable declaration, so it won't work. Here, though, this is fine, and this is fine because this was declared first. Now we're going to pop out of that code block now, and we end up down here. Is this a valid statement? It sure is, because this one actually is on the same level as these up here, outside the curly brackets. This one, can we do that? This is where it gets a little fuzzy. All right, this was stated up here, but it didn't work. And the reason it didn't work is it didn't have an int in front of it, or we didn't declare it separately. We came in here and we did declare it after a while. And so these two statements, the bottom two here, are valid. When we come out, we do that one, then we come to this one. This one exists outside that code block, so it reads it incorrectly. It has to be declared first. And then here, notice that we're coming out of the whole method, and then this is declared outside of it, also not going to work. Now, there's a couple little things to learn from this. One is that if you're working inside of a code block, you need to have a variable declared in order to use it. If you need to have one that's available to all of the whole program, you're going to use globals, which we're going to talk about. But also that if it's a really good idea to not use the same name for things in the various code blocks. So switch up the names. Now there's no reason you can't use the same name, but you may end up getting confused. So switch names. All right, so they keep going on this example here, and now they're doing exactly what I mentioned, is they're setting up two different blocks of code. So you see the curly brackets here, and they are setting up the variables correctly because they're saying int sumVar equals 7, so then they can output it, so they can use it, but you have to declare it first. But then you come down here and you're using the same variable, and this will work just fine. But for me, it's both an example of not naming it the same, and if they're really just doing something so simple, is this really the best way to do it? But they use the curly brackets as ways to isolate code. And they say don't declare blocks for no reason. And that's exactly what you're doing, because you're creating all this extra code and you're really not doing anything in particular. So. All right, they continue on with another example here at the bottom. And they start saying why this is invalid. So you don't want to declare the variable multiple times. So this very first line, it was declared. We don't need to do it again. It will throw an error, because at that point all you have to do is omit the int and it'll be okay. All right. Now, this is considered invalid too. It says even though this is a new block, this block is inside the first block, so it will work. Here, these two blocks are on the same level. They're equally in, you know. This block is inside the bigger block, So this won't work because that's already been declared. So what it's telling you is that if you just used this, that would be okay, because it has been declared one level above. All right. All right, let's talk about this. This is pretty important, at least, be familiar with the terminology. There is this thing called an override, and it says when you use the variable's name within the method in which it is declared. So let's say we got a little method, we're doing a bunch of statements, and we're using the name of our variable. It says any other variable with the same name in another method, we're overriding it. So, in other words, the more local it is, it takes precedence over the global. So if we're within a method, it's not going to look at what's going on outside of it. It's going to look at what is happening within it first. And that, you're best off seeing that as by just doing it. All right, so when variables have the same name, it says variables within methods of a class override or hide the class's fields. This phenomenon is called shadowing. So a variable that hides another shadows it. And that's kind of a weird little construct too. And that's also one I really recommend. You see it in action, you understand it much better. All right, so I'm going to move ahead here, and we're going to go to the first you do it. So let's go ahead and bring up our authoring environment. I am going to use JGrasp for right now. Okay, now we're going to begin working on the first you do it exercise, page 186 in chapter 4. And right now, like I said just a few seconds ago, if you're watching the video, I am going to use JGrasp, but a little bit later this evening I am going to talk about a couple other IDEs that you might consider using to do some of this work. They are not obligatory. You can use whatever tools you want. I just want to point them out to you because of their importance in this field. Okay, so it says here, start your text editor, open a new document, and these are the first few lines of code. So let's go ahead and grab these. I'm going to just do a little bit of indenting here. All right, so we have our public class, and then we have our main method. And it says add a statement that displays the purpose of the program. All right, so it's just going to say demonstrating block scope. And then we're going to declare an integer and do some output. Oops, apparently my copy didn't work because I did a highlight. I'm trying to anti-highlight and it's not working too well. All right. Declare an integer output it to the screen. In the next step, we're going to create a new code block. In this code block, let's paste it in first. And this is where indenting is pretty helpful. We're declaring another variable, y, and then we're going to do an output to see what x is and what y is. So you can see this is just an exercise so you can understand what the scope is doing. That's the whole point of this. All right, so now we are going to grab one more code block. And that's going to go right below this one. I wish all the indentations would follow, but they don't, unfortunately. All right, so there's our next code block. Now here, once again, we're declaring y, because we have to, because otherwise it won't work in the code block, because this block of code is separate than this one. So I have to declare y again. And then we're going to check and see what x and y are. And then it looks like we're going to throw a method in here to do some other work, but we haven't created it yet, so we'll get there. And that apparently is going to send this off somewhere, and then we'll see what the values are. Okay. All right, then we're going to throw in a little tidbit here just to see the value of x when we're done. And then we're going to create this other method that they were alluding to. And what I'm not clear on here is it says, just make sure we're putting it in the right. Okay, see? Easy to miss, right? There's a highlight for you. Okay, type in a closing curly brace, and that's exactly what my question was, which is, are we closing this? Now notice, are you guys seeing the problem here? They never put in an opening curly bracket here. So my thing is, right now I'm closing this one, and then I'm going to close the class, the whole class file. Okay, but now they want us to throw in a method right here. I'm going to create a little space first, and we are going to throw this bit of code in. So this is a standalone method. You can see its name is demo method. And then it also redeclares x and y. And then it does an output. And then once this method is done, because we're going to call it from here, then it's going to jump back to this line of code. So what this really is, it's an exercise so you can see that you can jump somewhere else, come back, what changes and what doesn't change, and is it working how you anticipate. And it's all to demonstrate where variables have scope. So let's see if there's any other code here. All right, they want us to call it demo block Java, which we already have. All right, so let's go ahead and save it. That's actually not the folder I want it in. And let's compile. And that's good. I would hope so. And let's run it. Now, after we run it, this is where I want to take a look really quick at what we got as an output. and trace through the program at the same time and figure out what's happening where. So that's my objective here. So it says, first line inside the main method, demonstrating block scope. It does an output. There it is. Then we declare a variable called x, all ones. Then we do an output. X, what is x? X is 111. Great. Now we go into a code block. We declare y, which is set to 222. Then we output x and we output y. Notice that x does read inwards. So in here, I can see what x is because this is inside that code block. Okay. All right, so we go to a new code block, and y becomes 333. We output x, we output y, and we get 111, 333. Then we jump to the demo method, which is at the bottom. It resets x and y, or does it? So that's my question to you. But it declares x and y internally to itself, and then it does an output. It says x is, and that's right here, 888, right, because we set it right there, and y is 999. Now we will jump back and we'll continue these lines of code, and those are going to be right below these demo methods. And then it says after x is 111, because x inside this big code block is different than this one. So even though that we gave x a different value here, this is isolated. Okay? And so that one stays 111, and y, of course, is going to stay where it was, which was 333. And then once we pop out, x is what it originally started with because we didn't change it. All right, so that's demonstrating the scope. Now let's jump back into our book, and we're going to look at another new concept here. The point of this next section, there's a couple different points to it, but here they're going to start sending stuff into a method, and just be really careful that you look at what the data types are for what you're sending in. You always want to be aware of that. One thing that does happen in Java, and it happens in some other languages too, is that if you're working with a particular data type and then you try to do some math with it, it might automatically change it to a different data type because it needs to in order to do the math. And that's kind of strange at first, but if you try to figure out why, and I have some highlights here to help us, and it says, in Chapter 2, you learn that Java casts variables to a unifying type when you perform arithmetic with unlike types. So if I have an integer and a double, they're two different data types, but in order to do math, we have to switch one to match up so we can do the math, because otherwise they're different. So here they're trying to explain how that happens, and here they're saying, for example, when you multiply an int and a double, the result is a double. Okay? And that makes sense because a double provides more information than an int. Okay? Okay, so it says in a similar way, Java can promote one data type to another when you pass a parameter to a method. So, in other words, you can throw in a number, and then by virtue of passing it in, you're changing it. So All right, here it's basically showing us in this example, it says either a double or an int can be sent to a method that accepts a double. So I can send an int into a double, but guess what? I can't do it the other way around. All right, so here they're also pointing out, it says a very similar example where they're calling two different functions. And notice it says the call with an int argument uses the method that is a better match when it is available. So I have two methods that are the same. One accepts a double and one accepts an int. And notice, same names. So if you're sending it like this and you're sending in an int or you're sending in a double, it's going to choose the one that fits it better. Now, I have no idea why you would do this, but you can. I think that's more the point than anything else. All right. Let's try this overload thing. So let's begin another new file. All right, and we're going to start a new snippet of code here. We're going to throw in this block of code. All right, and you can see here what the code does. It says int month equals 6, day equals 24, year equals 2015. It says display month, display date, month and day, display date, month, day, and year. So now we're going to create the three methods that go with, noticing that each one of them has the same name. See that? Mm-hmm. But each one of them accepts a different amount of parameters. So there's the first one. Throw in the second one. And finally the third one. Okay, so this one takes in month. All right, and then it says event date. It's just going to put out the month. What's it going to do? It's going to add it to the address text. This one will display the date, so it brings in the month and the date. So we're going to add those two in. And then the last one does all three. And just keep in mind, this is overloading. All right. Yeah, thank you very much. I will close my braces. And if I don't, it will probably remind me anyhow. And once again, I'm saving it. know why, but it keeps bringing me to that folder there. And let's compile it. Oh, we got an error here. It says line 27. All right, so do we have those two go together?
Oh, the last one, there's only one enclosing and bracing. You put two. Yeah, it's in
See
the
that?
one.
Does this one have a match? So you think we're okay now?
Yeah.
All right, good catch. All right. Now let's go ahead and run it.
Wait a minute. I think this is 2015.
Right, and Nancy, you're asking exactly the right question. Because up here, in the main method, we are declaring basically it's June 24th, 2015. Right? But here, when we bring it in the first one, we're only changing the month. So it's 6/1/2014. These are hard-coded. Here we're adding the date, so now we have 6/24/2014. And then here, we're changing all three, so that's the one we want. Overloading. All right, now that we've finished the You Do It exercise here on page 194, this video will end and you can move on to the next one where we'll pick up with the rest of the chapter.